I've had a few people ask me to share my spiral code, so I thought I would share that with you guys. Uh, Here is the code itself. I put a link in the description to the GitHub page, and if you need to find the GitHub page, it is going to be at github.com/slayman/UE-spiral, and there's just two code files, spiral.h and spiral.cpp. The code files themselves, they are all self-contained, so you can put these into your project or put them in a plugin, put them anywhere you want. It's all just super simple C++, and once you've put that in, all you do is you compile it and you're ready to go. So I'll talk a little bit about the properties and the functions within the spiral code, and I won't really go over the implementation code in the C++, but if you want, you can look at that if you're curious. So the things to call out, we have a spline component for our base track. We have an optional curve float reference, and you also have an optional curve scalar value. You have a default starting radius and a default end radius, and you also have a way to offset the spiral's theta value, and you can also specify the number of spirals that you have, and then you can specify whether that rotates clockwise or counterclockwise, and if you need to visualize it, you can draw some debug info. So all that said and done, once you build your project, all you do is you go into wherever you place that code. In my case, it's inside of my plugins, C++ classes, public section, and in here, I just take that spiral actor, drop it into the scene, and you are ready to go. So if you're happy with everything at this point, you can stop the video and run with it. Otherwise, we're going to go over how to actually use this, so let's dive right in. So when I was building this, I kind of thought of a spiral as a collection of circles that are spiraling around some sort of a point, and those circles can either be at a fixed size, or they can be growing or shrinking. So the way to think about these concentric circles is like you've got a wood lathe that's spinning around, and you've got a cylinder of wood that's going at roughly 1,000 cycles per second, and you've got a chisel that you can push into that wood lathe to create some sort of an interesting shape, and depending on where you press that chisel, you can create anything from like a candlestick holder to a goblet to whatever else you can imagine. But instead of creating like a goblet or a candlestick, we're creating the shape of the spirals as it moves around that lathe. So with that in mind, we'll start our super simple spiral here, and we will start drawing our debug info. So we have just one full circle that rotates around this center axis point, like so. And we start with a start radius of 100 and an end radius of 100. And then we can increase our spiral count to say like to 5. Oops, I meant 5, not 50. There we go. So now we have 5 circles here. And you can also modify the spline and stretch that out, and you will stretch out the dynamically generated spiral. We can also change our default start radius, so if you wanted to go from 0 to 100, you can. And now you have this cool looking little tornado thing. So maybe we increase from 5 to 30 spirals, and now you have kind of the shape of a tornado. But let's say that this tornado is too triangular, and you want it to be more like a funnel that has kind of like a curvature to it, right? So To do that, what you really want to do is have some sort of a radius curve. So let's go to our content drawer. We'll go to our curve section and we will call or create a curve. Go into miscellaneous, select the curve, take the curve float, select that guy, we'll call this tornado. And the tornado curve, let's say, so 0 is going to be the baseline for the curve. So any values below that you can pretty much ignore. So we'll put our first keyframe at x is 0, and then let's say y is equal to, let's say 5, oops, something like that. And then we want our tornado to gradually increase, so let's place another keyframe here, and then we want it to grow even more, so we'll put a keyframe there, and then we will take these and then use cubic interpolation, and then let's kind of like massage the tornado a little bit, something kind of like that. Looks good. We'll save this. We'll leave that open in case we need to do any tweaks. And then we will set this tornado curve right there. And as you can see, we start off here and then we grow to this value. So we need to go back into our tornado curve and definitely ramp up that this value right here. So let's just put it right up to 30. And kind of like shape it like this. Let's save that, go back, and then we need to refresh our debug, and that looks a little bit better. It's getting closer to the shape that we're looking for. Let's do one more pass. We want this guy to be maybe 60. Something like that. Refresh it, and now we have something that kind of looks like a little bit more of a tornado. So it starts off small, and as it tapers, it kind of grows and gets a lot bigger. So you could take this object right here, rotate, oops, we want to rotate the actor, not the spline itself. Go like this, let's rotate that by 90 degrees, and there we go. And then we can place this closer to the ground, something like that. Close enough. And now you would have a path for your visual effects to follow. So if you have like a whole bunch of dirt particles or fog particles or other particles, then they could follow this path. And you could also create multiple splines for debris that follows kind of like this tornado type of a path. But one thing you might also say is like, well, tornadoes, they are not just straight up and down. Maybe they're kind of twisty. So what we might want to do is just add a couple different spline points like this, and like this, and like this. And maybe move this guy down, just fiddle with it a little bit to create some twistiness to our twister. And we might be happy with this, but now we're like, okay, well, this tornado is pretty tall, but maybe we want to widen that out, but we don't necessarily want to just keep on fiddling with our curve values. So you can go back to your spiral, and we have our curve scaler right here, and this will scale the radius of this. By default it's 1, so it's not applied, so let's go with the value of 3. That's pretty extreme, so let's go down to 2. And then maybe we adjust this a little bit, pull this out a bit, and as you can see, you can kind of play with this. So this is a pretty easy and cool tool to use. If you have this actor highlighted, you can go into a level blueprint, create a reference to that guy, type in spiral, and then you can get a position at any given distance, or a position at any given angle. And these are going to return the world space coordinates for any point on that red line given a position along this spline, or some sort of a theta value. Anyway, I think that covers it pretty much. All the controls that you need are just here in this spiral section, so I think that about sums it up. If you have any questions, go ahead and post it in the comments, and I will try to reply if I can.